Okay, guys, today we focus on a specific type of sequence. So far we've been looking at lots of patterns, and today we focus on arithmetic sequences. Now, what does arithmetic look like? And even sometimes people pronounce it arithmetic. And you do want to actually think about arithmetic as you're looking at an arithmetic sequence. So before we start working with arithmetic sequences, let's just see when can you recognize one. So take a look at the two columns. And let's see what's the difference in these two sets. So looking at number 1, 2, and 3 in the left column, starting with number 1, what's happening to get to each term? Multiplying by 2, I heard it, awesome. If we take this and we just times it by 2, we can stay consistent and multiply by 2, so on and so forth. So number 1, you're multiply by 2. Number 2, if we're sticking along those lines of multiplication or even division, what would you say is happening in number 2? Yeah, divide by -3 or multiply by -1/3. Either way you want to look at it. In the future, we're just going to be looking at it in terms of multiplication though, so we'll just say multiply by -1/3. Number 3, what would you be multiplying by? E squared, excellent. Multiply by e squared. Now, one of these columns demonstrates an arithmetic sequence, and the other one defines geometric. Which column do you think this would be? Geometric or arithmetic? Geometric, good. Geometric, and although you guys haven't been taught this yet, geometric is when you are multiplying by a constant to get to each term. Multiply, multiply. So these in the left column are geometric. Let's take a look at the right column. The right column, what's happening between each term? Good. We're adding a value of 3. How about number 2? Adding 2 to it. Good. How about number 3? You're adding ln2. And that is actually correct. Let's think about why that works. Think about your product property. What is natural log of 2 plus natural log of 2? What do we do with those two numbers? The 2 and the 2. Multiply. So it's actually equal to natural log of 4. So yes, we are adding a natural log of 2. Natural log of 4, if we add a natural log of 2 to that, it becomes natural log of 8. Natural log of 8, if we add a natural log of 2 to that, it becomes a natural log of 16. You guys remember this, the product property? So yeah, we're adding natural log of 2. These, what you just saw, are defined as arithmetic. The reason they're arithmetic is because you are adding what's called a common difference to get to each term. So all of these that we just found, the number 3, the number 2, the natural log of 2, the number that you add to get to each term is defined as the common difference. We'll want to write that down because we're going to use it all throughout today's lesson. So the number that you add to get to each term is the common difference, is what it's called. Common difference. And we often just abbreviate that word common difference with just a little d. Why do you think it's called the common difference? If you're adding a number to get to each term. Yes, I love it. Olivia said if you go the other way, if I do 8 minus 5, so subtract the term before it, I can find that common difference of what's been added. So that's why it's called the common difference. But one thing that is true of arithmetic sequences is you have to always add the same number to get to each term. If I was adding like 3 and then 4 and then 5 and then 6, that would not be arithmetic because I don't have a common difference. I don't have the same number to get to each term. Okay, so we're going to take a look at how we can generalize a formula for any term in an arithmetic sequence. So let's go ahead and let's just take a look at the pattern. If you had negative 12, then negative 7 as your second term, negative 2 as your third, 3 as your fourth term, and 8 as your fifth term. We're going to write out how do you get to each term, and we're going to try to generalize it off on the right to see if we can come up with a formula that would work with any arithmetic sequence. So notice, if the first term is negative 12, we're going to call the first term on the right just A1, representing that it could take on any value. But if it's negative 12 at the left, what would I have to add to that to get to negative 7? Add 5. Good. So I'm taking negative 12 and I'm adding 5 to it. So if I'm generalizing this off to the right, that means you're going to take the first term and you're going to add, what do we call that number, the number you're adding? Common difference. So we're going to add D, which is your common difference. Okay, we simplified here, negative 7, but how would I get from negative 7 to negative 2? I'd add 5, I'm going to add a D. So if I think about my thought process, I took the first term, I added 5, and I'm adding 5 now again. If I generalize that to the rule off to the right, you took your first term and you added how many D values? 2D, exactly right. Okay, let's keep going. If I'm at the third term of negative 2, what would I have to do to it to get to the 3? Add 5. So if I'm generalizing, or if I'm looking at what am I doing, I'm taking negative 12 plus 5 plus 5, that answer, which is negative 2, and I'm adding 5 again to it to get to the next term, 3. So if I want to generalize that to how you would find the fourth term off to the right, you would take the first term, and how many D values would you add? 3 plus 3 Ds. Let's think about it one more time. So if we get to 3, and now we have to get to the fourth term, or the fifth term, which is 8, I would have to, again, add 5 to it. So my thought process is I took the previous term, which came from negative 12 plus 5 plus 5 plus 5, and I'm adding 5 again. How many D values did we add? 4, 1 less than the term that we're at. I'm at the fifth term, and I'm adding 1 less D value to the first term. So let's see if we can generalize that now to a formula for an arithmetic sequence. Any term, so n represents any term, you can plug in any number for n, is going to equal what? What would be the formula? Well, what stayed consistent? A1 plus the number that changed is how many times you're multiplying D. In the third term it was 2, in the second term it was 1 times D, in the first term you could say 0 times D, fourth term it's 3 times D, so what would be the nth term? Exactly right, n minus 1 times the value of D. So this is our formula that we're going to work with, be able to know and how to work with it when you're given just different pieces of your arithmetic sequence. So this is the formula to find any term in your arithmetic sequence. Okay, with that said, use that discovery to solve for number 1. Find the third term, A3, and a formula, AN, that would generate the specific sequence described. So go ahead and do that with your partner with number 1, and then we'll check our answer. Let's go ahead and check our answer. Notice that this formula can be simplified. When we put in negative 3 for the first term and negative 4 for the common difference, we don't want to stop there because we can combine some like terms here. When I distribute the negative 4, that becomes a positive 4, and then I can combine that with negative 3, so my actual formula just can be simplified. So wherever possible, always simplify when working with algebra. So AN is equal to 1 minus 4n, and then we could actually use that formula instead to just plug in if we're finding the third term. That means our value of n is equal to 3, and so we can plug that in. Questions on that? Okay, let's take a look at number 2. Number 2, we have the 15th term and the 17th term. To find a formula, an, let's think about what an is. Any term can be found using the first term plus n minus 1 times the common difference. So what 2 pieces do you have to be able to fill into the formula for it to work for a specific pattern? Yeah, we've got to find what is the value of A1 and what is the value of D. Let's start with D. If I know that the 15th term is 8 and the 17th term is 2, let's write it as it would look in the pattern. This would be the 15th term, would be 8. I'd be missing a term. I don't know what the 16th term is. But the 17th term I know is 2. Take a second and talk through with your partner how you could determine either what the middle term is or really what the common difference is, what you're doing to move to each term. All right, guys, as I was walking around, I saw good things. I saw many people say that the common difference, what you're adding to get to each term, is -3. Because if I add -3, I get to 5, and then if I add -3 again, then I'll get to 2. But I want to have just a strategic way, maybe a formula, for how I can always do that. If I'm missing, like what if I have 5 terms, and I want to find what's the common difference between them? The rule that works is if you take the difference of the value of the terms, so if I took 2 minus 8 and divide it by the difference in the term numbers, so 17 minus 15, what's 17 minus 15? 2, so 2 minus 8 is -6. -6 divided by 2 tells me that my common difference is -3. So that's just kind of the rule of thumb. Some of you can just figure it out, but as the numbers get larger, you might want to have a formula to help you. So the formula for finding the common difference is, you can take the difference in term values, difference in term values, and divide it by the difference in term numbers. And just to give us a sample of how that works, we could go ahead and do it right here. Our common difference would equal 2 minus 8 divided by our term numbers was 17 and 15. So over 17 minus 15. And that gives us our -6 over 2, which tells us that our common difference would have to equal -3. Just to see how that works. All right, now if I know the common difference, any ideas of what I could do to find the first term? Just plug in things. I know the 15th term, so when n is equal to 15, the 15th term has a value of 8. So the value of 8 is going to equal my first term plus, what's the value of n if I have 8 to the 15th? 15. So 15 minus 1 times, what's my common difference value? -3. And then I can work backwards to solve for the first term. So 15 minus 1 is 14. 14 times -3 is -42. So I have 8 is equal to the first one term plus -42, or you could have just said -42. And then how do I solve for the first term? Add 42. So what's the value of the first term? 50. 50 is equal to the first term. So now I have the information I need to make the generic formula. The formula to find any term for this specific pattern is any term can be found by taking the first term, which is 50, plus the number of the term you're trying to find, which is n, minus 1 times my common difference, which is -3. Can I simplify that, or should I leave it like that? Simplify it. So we'll distribute the -3, which gives us 50 minus 3n plus 3. And that just leaves me with 53 minus 3n. And then what else did the problem ask us to find? The third term. Now some of you who are more like pattern oriented, you could just list out these terms. And if you know the common difference, and just go ahead and add 3 and say the previous term would have had to have been 11, and the previous term would have had to have been 14. But if you didn't see that, you could just say, okay, what is, or if you didn't want to think like that, you could just plug in your numbers. The third term is going to equal 53 minus 3 times the value of 3. You're just plugging that in. Yeah, I think I did. I said it was 14, but I wasn't thinking clearly as far as the third term. Oh, because I was at the 15th term. Yeah, we wouldn't want to think 15 terms behind. I was thinking it was the 5th term. Sorry. So we plug that in, and we would have 53 minus 9, which would give us, what would that come out to be? 50, yeah, 44. How are we doing so far? Give me a thumbs up, side or down. Okay. All right, let's go to the next one. Why don't you try this one with your partner? I'll come around, see if I can answer any questions, and then guys, go ahead and check your work. I started with the generic formula, and I said, okay, any term can be found using the first term plus n minus 1 times d. Then I worked backwards with the fact that I knew what the second term was. So I said when n is 2, the term comes out to be y plus 1. So I said y plus 1 is equal to the first term plus 2 minus 1, because n is 2, times negative 3. And that's how I found the first term. If you were thinking in terms of a pattern, this is the pattern that you are envisioning. If I look over here up on the board, this is Mr. Felinsky's work, obviously, because I'm short and I can't barely even reach this. But he has the first term, second term, third term. If we know the second term is y plus 1, and the common difference is negative 3, that means we add negative 3, and we see that the third term is y minus 2. Or we could go backwards and think about adding 3 to get to the previous term as y plus 4. Or you can just use the algebra, use the equation, and figure those pieces out as shown on the screen. Any questions on that? Okay. Okay, last thing we want to be able to do with arithmetic sequences is we want to be able to consider partial sums. What's a partial sum? That's looking at all the terms in a sequence and adding them together, just like the kindergartner, Frederick, and I found out that I've been mispronouncing his name. It's Gauss. So sorry, Frederick Gauss, what he did way back when. Do you guys remember when he added all the numbers from 1 to 100, what the answer came out to be? 5,050. Exactly right. It's 5,050. Now, thinking about his sequence, think about each term. This is the first term. This is our a sub 1. This is our second term, our a2. This is our third term, a3. Would this term be considered, or this sequence, if you're just looking at the pattern of those numbers, would it be considered geometric or arithmetic? Arithmetic. What would be the common difference? Common difference is equal to 1. Now, what Frederick Gauss found, or what he did, just as a quick reminder, is he found the sum of 100 terms in an arithmetic sequence. So S sub 100, remember that means the sum of 100 terms, in case you forgot that terminology, but the sum of 100 terms is equal to, remember he added the first term plus the last term. How many times would he have to do it? 50. So it was the first term plus the last term multiplied by the number of terms divided by 2, because he was pairing them together. So it was multiplied by 100 divided by 2. What he did will work on any arithmetic sequence. Here's what it would look like. The sum of any amount of terms is equal to the number of terms. So Frederick had to add 100 numbers together. His number turned out to be 100, but it will actually work for any arithmetic. So the number of terms divided by 2 multiplied by the first term plus the last term, the nth term. So just to kind of give yourself some just some reference, make sure you know what each of those values equal. So let's go ahead and let's rewrite it in this box. S sub n is equal to n over 2 multiplied by the first term plus the last term. And let's just give ourselves just some terminology. S sub n is the sum of n terms. N is the number of terms. A1 represents the first term. And AM represents the last term. Just like Frederick was adding the 100th term. Now another way, this is the best way to think of it, but we learned what AN could be replaced of. We learned how to find any term. So one thing to be aware of is, or you could look at this by just replacing that formula in for AN. So the sum of any terms could also be seen as n divided by 2 times the first term plus what we know of how to find the nth term, which in an arithmetic sequence is always the first term plus n minus 1 times d. So just to kind of show you, you can use the previous formula within this one, just because that matches the same thing. All right, let's see if we can do it with number 4. Find the sum of the first 10 terms. So here we're looking at the sum of 10 terms is going to equal 10 divided by 2 multiplied by the first term plus the last term. So what do we have to find in order to be able to find this sum? The first term, the last term, we need the common difference, right? Well, this one's kind of nice to think about. I could use the common difference formula, but if I see that the third term is 5 and the fourth term is 8, what's the common difference? 3. We see that we're adding 3 to get to each term. You could have done 8 minus 5 over 4 minus 3. That would work. But yeah, our common difference, or not equals, I should say the common difference is equal to 3. Now how can I use that to find my first term? You could plug it into your formula. You could also go backwards. This is your second term. This would be your first term. What number plus 3 would give me 5? 2. And what number plus 3 would give me 2? Negative 1. So now I know my first term is negative 1. So I can plug that in as my first term. 10 divided by 2 multiplied by negative 1 plus, how can I find the 10th term? Yeah, we can just use that one formula. The 10th term is found by the first term. What was our first term? Negative 1 plus 10 minus 1 times my common difference, 3. So it would be negative 1 plus 9 times 3. It would equal negative 1 plus 27, which is 26. So we plug that in, we add those together, and the sum comes out to be 125. All right, guys, you have enough.